Let's learn how to use substitution to solve equations like x to the fourth minus 8x squared plus 8 equals 0 using techniques from solving quadratic equations. Notice that the largest exponent, x to the fourth, is twice the other exponent, x squared. So if we set w equal to x squared, we can get a quadratic equation in a new variable w, and then we can use techniques for solving quadratic equations. So let w equal x squared, then w squared equals x squared squared, which is just x to the fourth. So now let's take our equation, x to the fourth minus 8x squared plus 8 equals 0. And we're going to replace the x to the fourth with a w squared. We're going to replace the x squared with a w. And now we can use any one of our techniques from solving quadratic equations. Well, gee, can we factor this one? Well, 1 times 8 is 8, but the only factors for 8 are 1 and 8 and 4 and 2. And that'd have to be negative, too. And negative 1 plus negative 8 adds to negative 9. Negative 2 plus negative 4 adds to negative 6. Right? So this does not appear to be factorable. We could check for sure by using the discriminant. So let's use the discriminant. As a reminder, the discriminant is b squared minus 4ac. All right, so that would be negative 8 squared minus 4 times 1 times 8. And that would be 64 minus 32, which is 32. Now 32 is not a perfect square, so we're going to get two irrational solutions. We're going to have a radical, so factoring isn't going to work. But we can use completing the square, right? So not factorable. But this looks like a nice one for completing the square. All right, so we're going to subtract 8 from both sides. So w squared minus 8w equals negative 8. And then we'll add that number that makes this a perfect square on the left-hand side, which is simply half of 8 squared, half of b squared. So that gives us w squared minus 8w plus negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So negative 8 plus 16. On the left-hand side, that factors easily into w minus half of b. Well, half of 8 would be 4. All squared equals 8. Now we can take a square root of both sides. So the square root of w minus 4 all squared equals plus or minus the square root of 8. On the left-hand side, square and square root cancel. And then we can simplify 8. Right? 8 is 4 times 2, 4 is 2 times 2, 1, 2 comes out, 1, 2 goes away. And 1, 2 stays in the radical. So w minus 4 equals plus or minus 2 square roots of 2. And then we can add 4 to both sides. So w equals 4 plus or minus 2 square roots of 2. And you might think, hey, we're done. But we're not done, because we didn't solve for x, we solved for w. So we have to substitute back. So I'll just put a little reminder there. Remember to substitute back. All right, so this is going to be x squared, because w is x squared, equals 4 plus or minus 2 square roots of 2. And we don't want to solve for x squared, we want to solve for x. So that means x is equal to the square root of 4 plus or minus 2 square roots of 2. And I wish I could tell you that you could make that look nicer, but when they're combined with addition and subtraction, we're kind of stuck with it. So, oops, and we don't want to forget to do plus or minus. All right, so when we take a square root, don't forget plus or minus. So we have, I'm going to write that a little nicer. We have 4 solutions here. And let me show you the 4 solutions. So we have x equals the square root of 4 plus 2 square roots of 2. We have x equals the square root of 4 minus 2 square roots of 2. We have x equals negative square root of 4 plus 2 square roots of 2. And we have x equals negative square root of 4 minus 2 square roots of 2. So those are our 4 solutions there. They're all rational, right? So this would have 4, if we were to graph this equation, it would have 4 x-intercepts. And those are our 4 solutions. All right? So you can substitute anytime you've got one variable, the exponent twice as large as the other exponent. So x to the 6th and x cubed would work. X to the 8th and x to the 4th would work, right? In this case, it was x to the 4th and x squared. You just have to remember after you substitute to substitute back, right? Let's try another one. And this one will also be using substitution, but it'll look a little different. Find all solutions of the equation x to the 1/3 plus x to the 1/6 minus 2 equals 0. Well, I know that a third is twice as big as a sixth, right? Takes 2/6, right, to equal 1/3. So we can use the same technique again. So let w equal x to the 1/6. Then w squared equals x to the 1/6 squared. Remember when we raise power to a power, we multiply exponents. And 1/6 times 2 is going to be 2/6 or 1/3. All right, so we'll rewrite x to the 1/3 plus x to the 1/6 minus 2 equals 0. As w squared plus w minus 2 equals 0. And now we have that to solve. And doesn't that look so much easier than the equation we started with? And this one I think is factorable. But let's say you weren't sure. You could use the discriminant again. As a reminder, the discriminant is b squared minus 4ac. So that would be 1 squared minus 4. A is 1, it's the coefficient on w squared, and c is negative 2. And that would be 1, there's 2 negatives there, so that would be plus 8, so that's 9. That's a perfect square, so this is factorable. So we should just factor. Multiplies to give us, so 1 times negative 2 is negative 2. Multiplies to give us negative 2. Adds to give us positive 1. That's going to be 2 and negative 1. So we'll keep the w squared. We'll replace the w with a 2w and a negative w, and we'll keep the 2. And the first 2 become a group, and the second 2 become a group. We can factor out a w. That would give us a w plus 2. Negative w minus 2, we can factor out a negative 1. That'll give you a w plus 2, which is exactly what we needed. Now we can factor out that repeating w plus 2, and we're left with a w minus 1. We'll set our factors equal to 0. So w plus 2 equals 0. W equals negative 2. And w minus 1 equals 0. W equals 1. But wait, we're not done. We solved for w, right? And we want to solve for x. So w, if you remember, was x to the 1/6. So x to the 1/6 equals negative 2. And x to the 1/6 equals 1. Well, what are you going to have to do to solve for x? Right? If you've got a 6th root of x, right, that's what that is, you've got to raise it to the 6th power, right? So if we raise this to the 6th power, when we raise power to a power, we multiply exponents. 1/6 times 6, well, that's just 1. And so this is just going to be x. And now we just have to do the same thing to the other side. So we have to raise this to the 6th power. All right, so negative 2 to the 6th power, that's going to be 64. And x to the 1 6, we have to raise that to the 6th power. And the 1 to the 6th power, of course, that's just going to be x equals 1, because 1 to any power is 1. Now, we did go raise things to powers, and sometimes that causes us to have extraneous solutions. So we should probably check to make sure that this would work out. All right, so we'll plug in the values and see what happens. All right, so our equation, I'm just going to clone this page so that I can have the problem on the next page. Yeah. And somehow I think I just got one of them. All right, let's erase this. We can remember 64 and 1. All right, so x to the 1/3, that's the same as the cube root of x, remember? And x to the 1 6, that's the same as the 6th root of x. All right, so let's plug it in. So cube root of 64 plus the 6th root of 64 minus 2 equals 0. And this is the check. The cube root of 64 is 4. The 6th root of 64 is 2. And since when does 4 equal 0? All right, so this one was an extraneous solution. So 64, x equals 64 is extraneous. That sometimes happens. Remember, we raised a negative to a power, so that kind of should make us alert to the fact that we might have a false solution now. So that's an extraneous solution. That didn't work out. Let's try 1. So we have the cube root of 1 plus the cube root, the 6th root of 1 minus 2 equals 0. All right, so cube root of 1 is 1, and the 6th root of 1 is 1. And that one checks out because 2 minus 2 is indeed 0. So our only solution that was a good solution is x equals 1. Now, you don't have to check all of your solutions. You just have to check when you're raising to a power, because all of a sudden things that weren't solutions before become solutions, and then when we check them out, they don't work. All right? So that's the end of this podcast. Thanks for watching, and bye for now.